So I'm Maxime Agostini. I lead Applied AI product for Applied AI at Datadog. And we're going to talk about how observability has changed in the world of AI with new tools, new expectations, and how we can manage this with new solutions. If you don't know about maybe about myself first, I come from the startup world. I started the first company in machine learning. At that time, we didn't talk too much about AI. Sold that company to Yahoo AOL. Started a second company that was acquired by Datadog a couple of months ago. And I took over product for Applied AI then. And Datadog, if you don't know about Datadog, it's a big US company. We're talking about 30,000 customers with a lot of names that you may recognize here. And we are a key player in observability and everything around observability, starting from infrastructure monitoring, logs, application performance monitoring, security, and pretty much everything around. So this is the full extension of Datadog products. I'm not going to talk to you about all of those products. My role at Datadog is to bring AI to automate how those products work and how people work with those products, which is what we're going to talk about. But first, let's take a step back and look at the world we live in and how it's changed over the years. So there's this, like you have all those curves that look at the complexity of having systems in productions. You have systems that are like have more and more solutions and technologies packaged together. They go at larger scales with a larger number of hosts or a number of underlying machines to run them. You have more people contributing to the systems. The teams are getting bigger, and you have like a lot more pace in terms of how you release. So all of those compound to a world where people ship more code more often and at a scale that's never been seen before. This is kind of the world before AI, but now there's a new player in the room, which is AI system and agents. So here is a nice graph that shows like the length of a task that an agent or an LLM can do, which is doubling every 7 months. So it started from like simple autocomplete stuff a couple of years ago, but doubling every 7 months is huge, which means that we already at a frontier here where an agent can work in autonomous fashion for hours, and probably even more soon. And it's getting cheaper and cheaper as well. So here you see the cost frontier of models, and it keeps going up and to the left, up to a point where it's very cheap now to have human PhD ranged intelligence at cost of a couple of dollars. So this is something that is completely changing how we are considering like moving products to productions. And you have a couple of stats here from interviews from Google CEO and Microsoft CEO saying that now 20 to 30% of the code that goes to productions involves some component of AI, whether it's being reviewed by AI or being completed by AI. And so now AI systems are writing the code. And this is also, you have new tools like Cursor that reached $100 million ARR in a matter of 2 years, I think. So people are going to push code to production in a way that was never seen before. So those numbers here, when you think 20, 30%, you're talking about like the biggest players in the world. They already have 20, 30% of the code being pushed by AI. If you look at smaller players, there was this stat from the last Y Combinator batch. I think there were a quarter of the batch that had more than 90% of the code being entirely written by AIs. So 90% is huge, but those are the companies of tomorrow. So the big company is starting with 20, 30% because that's the way they can make the code base evolve, and the code base is pretty big. But when you start greenfield, we're talking 90%. So what does it mean? Well, if you have 90% of the code that's written by AI, doesn't mean that people are not going to push code anymore. It means that we're going to push 10 times as much code. And this is going to completely change how we push code to productions, we ship systems, and we're going to monitor those systems. And that's where Datadog comes into play. We need to rethink what is observability when the pace is 10x or 100x, which it used to be. So it used to be, well, you monitor systems and you put it in a dashboard, and some humans will go in on the dashboard and try to find out like whether there's an incident, how to address it, how to collaborate on an incident. But this is not the right pace anymore. We're talking about maybe systems that will ship code and fix code and auto-heal systems automatically at a pace of every hour, every minute, or whatnot. So this is not, the human scale doesn't work anymore, or will not work anymore really soon. So now we're looking into an entire loop where agents and AI systems can observe, well, that's where we start from, but also guide the decision of the fixes or any optimization or any remediation decision, and take action. So this is, well, we're not there yet, but this is where we're going. We're going to have the entire loop of monitoring and optimizing code that's going to have to keep track on, keep the same pace as the pace at which we ship code. This is what we're working on at Datadog, and it's really set up around 3 pillars. The first one is how we use AI ourselves. So in the products that we deploy, we have more and more AI components so that the experience of the users are based on AI, automated AI decisions. But also we want to play nice with external AI systems. A lot of people are using Cursor, a lot of people are using ChatGPT to automate some tasks, and those tasks get more and more complicated. We want to be able to play with those players in the sense that those automated systems, automated agents, will want to be able to know how are my systems going, how can I fix this, is there an error, who should I call, and so on. So those decisions are going to happen outside of Datadog, but they're going to be driven by agents and automated systems, no longer by humans. So we want to be able to have AI that talk to other AIs, and this is another pillar on which we're building AI at Datadog. The third component is AI observability. So it's not just about using AI to fix your systems, it's also about using observability, fixing AI systems and observing AI systems. So we have a deep investment in that space. So first on the how we use AI, I'm going to give you like a broad representation of what we work on. I'm not going to go deep into the details. I'm going to be happy to talk about that later. But the idea is always to automate the operations around security systems, infrastructure monitoring, performance monitoring. We want to automate as much as can be so that the task, the onus of fixing all of that is as much as possible automated. This is at Datadog like built on top of like strong foundations. You don't build AI just from the top and say, okay, well, you have shaky ground, but you're going to have this very smart agent at the very top, and it's going to be able to navigate all of this. If you want to be like ship systems that do work and not just in a demo, but work at scale and at the scale of your clients, you need to build that on strong foundations. At Datadog is first this core platform. So we have the fastest and the biggest system to process, I think the data is trillions of data points per hour of observability data, so no one else has this scale of data that we built automated system for. On top of which we have machine learning models that do the processing on the fly. And those are more traditional AI-driven systems that can process all of that data. Now, when we're entering a world of large language models, that means that you need to interface with those systems in a new way, which actually is English. You need to have natural language capabilities built into those APIs if you want to be able to make the connection between an agent or a chatbot or someone like chatting and setting prompts and those automated systems. And this layer is actually a non-trivial one, and this is a natural language capability that we're building on top of those AI systems. And once you have all of that, now you can actually build agents. So have autonomous agents that do and make decisions based on your observability data. They need to have all those steps in between to work. So first on the core foundations, at Datadog we have a research lab that we've started this year. It's publishing actually today a first paper on, well, we're releasing today the open weight observability model that's completely destroying the state of the art in predicting and forecasting. And we're also releasing and open sourcing a benchmark, like the biggest data set of the observability data as a benchmark. So this is the first kind of big achievement of that research lab that started in the past few months. And this is also an illustration that we see those core platform also as investing in foundational models. Like you've heard probably about foundational models for chat, but we're building foundational models for observability data. So how do you predict like how a time series is going to go based on what the systems look like and the metadata and all of that? We have a foundational model for this. Now the second layer is the automated systems that make decisions for you. We have a software called Watchdog that's watching your systems automatically without having to require any setup. We'll find all anomalies, we'll find root causes when some systems will go down. We're able to navigate all of that and bring the right information to you with no effort. Well, we're talking again about trillions of data points per hour. So you do want to have automated systems that take care of that. You don't want to be having to tune things manually. And if you have 30,000 customers, similarly, you don't want to have to do anything manually. Interestingly, we released in the past few weeks this new service where we're actually watching also the external services. You've probably all seen like status pages of services. Sometimes they go down. You don't know if your systems are down because something's wrong on your side or on an external provider. So we use all our telemetry data to capture that. The funny thing is that oftentimes we capture the outages before the status pages, or sometimes they never publish the status pages, but we do know that they were down up to 45 minutes before. So instead of being like all hands on deck because something's broken, we tell you right away that, well, this is because, I don't know, OpenAI is down and all your chatbots now no longer work. On the layer on top, we help you navigate like events. We have a solution called event management, where from a stream of events that could be billions of events, we do automated deduplication and correlation to go to actual cases that make sense and are worth investigating, and we show that like in a very condensed way. So it's something that makes it a lot easier to do the operations and fixing the systems. It's also going to make it a lot easier for our agents to make decisions. So those are some of the metrics that we track. We track like how many tickets that you actually have to deal with. So we want to reduce the number of false positive. We want to reduce the time to detection. Actually, the holy grail is reducing the time to resolution, so up to 47% lower time to resolution. It's a good first step. The day we have the agents automate the resolution and remediation, we can get that down to 99% down or something like this, because we can make those decisions automatically. With all those strong foundations, now we can build the layer on top, which is the agentic layer. We are building agents that make those decisions for you. So today we're working on those 3 agents, but they're the first 3 of a big family. The first one is the AI developer. Second one is the AI on-call engineer. And the third one is the AI security analyst. So the AI developer is really what it says, but it connects to your errors and your traces and brings fixes directly to you. So it uses frontier models off the shelf from the vendors you know, but it connects to your code base, and it connects to your errors, and it tells you right away, well, there's a spike in error here that just started, but oh, by the way, we found the root cause. It's because of this system, this new version that's down, and we also found a fix. And here's the fix. You just need to push a button to push. Tomorrow, maybe we'll just automatically fix it. Today, we just surface the fixes. So this really considerably reduces the time to resolution, especially because you can just go through all the errors and just click through, and you're fixing things as they come. There's dynamic instrumentation. You can also see that in your IDE. So this feedback loop is getting shorter and shorter as we speak. The second agent is really the SRE agent, so the on-call engineer. This is how to take care when there's an incident in the middle of the night. How do you go about it? So you're getting paged, your systems are down, and what should you do? Well, first, there's a run book to go through, but you just have 2 hands, And what the system will do is that it will automatically explore all the potential root causes. So call all the systems, summarize what it's found, push that onto your Slack channel maybe, or on Teams, and make sure that this information flows so that you have everything in a centralized place. The goal is that automatically we can find a root cause, but oftentimes it's a conversation between your teams, your operational teams or SRE teams, and the chatbot that's just multiplying the amount of work that you can achieve. And finally, the third family, or the third in the family, the security agent. So the idea here is to help with security decisions and mostly triage. When you have security roles, you want to capture everything, so you don't want to miss out on a single false, true positive. So usually you have tons of alerts. And the problem with those alerts is like most of them are not worth spending time on, but you need some automated way of doing that. And today what people do, they have people reviewing alerts like day in, day out. 90% of those could be dealt with automatically, and this is what the security agent is doing. It's using all the information that you can put into a frontier model to make those decisions when just the data point itself doesn't have enough information to be processed automatically. So it will pull information from different places and have intuitions built upon dozens and dozens of cases on what should be brought up or not. The idea is to reduce the number of alerts that you get by 10 or 100x so that you spend time on the ones that really, really require your attention. In case of security, sometimes you do want to be alerted even though it's benign, because there might be some rules you want to change. So it's not just whether it's an actual case of fraud or a hacker, but it also may be an illustration of something going wrong that you want to be aware of. So there's this gray area. There's always going to be a need for manual review rules, but you can automate 90% of it. The second pillar is playing with others. We are here presented how we build agents and we build capabilities, but a lot of people are building agents outside as well, starting from Cursor, which is an agent by itself. And you want to be able to talk to them, or you want to be able to build agentic applications that rely on observability data. For this, the main investment we have is the MCP server we're working on. So if you've been following the industry, I think this is the hottest term in the past few months. This is really the lingua franca of how models and tools can talk to each other in a world where text kind of took over traditional APIs. And with Datadog MCP server, we want to expose all those smart capabilities to others. So the logic could also be built outside. Because sometimes we would be lacking context. Maybe you're building an agent at your company, and that agent is aware of context that's within the company and it's not within Datadog. So the investigation requires this access to like multiple sources, maybe multiple MCP servers. So we want to be able to be plugged in. And one illustration of this kind of change of mindset is this new feature we just launching this month, which is natural language querying. So now you can query your logs in natural language. You say, okay, well, what are the error logs for the system? Oh no, I'm talking about like last week or so on, and it just gives you like the answer right away. This is one step towards making all of those underlying capabilities fully available through agents and MCP servers. And finally, I want to touch on this last pillar, which is when you guys build like AI applications, you also want to monitor those AI systems with AI. And we've released LLM Observability, which is a platform that gives you a 360 view of all your LLM applications. It gives you access to the metrics that make sense when you're tracking LLMs, which are not just like latency and errors. You also care about like number of tokens, costs, hallucinations. You want to know how many calls have been made into a particular workflow, for example, and be able to trace it back to questions and answers, see if there's model drift and all of that. This is bundled into this new product we released last year, which is LLM Observability. So maybe just to save a couple of minutes for questions, the key takeaway here is that the way systems, applications are built is changing. It's getting a lot faster. there's a lot more people that are, there's very few people, you can ship a lot more, and someone is going to have to make sure those systems work. But it's not just at the code level, it's how you make sure the code talks to the infrastructure. And when you ship a lot more code, how does it impact the infrastructure? And when you have a lot of new load on the infrastructure, how do you fix it in the code? And this feedback loop is taking a completely new shape because no one understands the code, will understand the code as it used to be. And that's why you need AI to have the automation of the loop. Today with Cursor, we have the automation of shipping code. I assume like you're familiar with Cursor, but Cursor is the number one IDE, so developer tool that lets you ship code by talking to an agent. Number one, I guess, by some metrics. But it's one of many. Everyone starts like using Copilot, Windsurf to ship code, or completely automate things with tools like Devin or OpenAI that can build applications from the ground up. But they don't really know how those systems work, how do they work in real life, how do they work with the current customers you have and the current loads. We want to make sure this loop works and auto-heals, and for that you need to automate the remediation when something goes wrong. This is where Datadog has a key part to play, and this is where AI is also critical. So thank you very much, and if you have questions, I'm more than happy to continue conversation.